In this presentation, we are going to talk about the confidence interval on the mean when we know the variance. And essentially what I'm going to do is I'm going to explain the concept of what the confidence interval is on the mean, and then I'm going to compute an example of the confidence interval so that you can actually see it. So when I'm talking about confidence intervals, the general idea is that we have samples from a distribution and we don't know the mean of this distribution, and we want to know what the sample tells us about the mean. A confidence interval is essentially an interval that has a given probability that it contains the sample mean. And what we do is we can actually go and compute the confidence interval using three different things. And the first thing is x bar, which is our sample average. Our standard deviation, and then our n, which is our sample size. And again, we can use these to compute the confidence interval. So associated with the confidence interval is the confidence level. And usually we express this as a percent. So you've probably seen this before as, let's say, 95% or 99%. And essentially it's the probability that our confidence interval holds the true value of the mean. So for computation's sake, we actually use this form of the confidence level in terms of alpha, which in the case of 95%, our alpha is 0.05. So you can see that we can compute our confidence level based off of our alpha by simply subtracting 1 from alpha. So in this case, we get 0.95. And then we just put this into a percentage by multiplying it by 100, and it becomes 95%. So similarly, with 99%, we have an alpha of 0.01. To compute the confidence interval, what we have to do is we actually have to calculate a lower and upper bound because it is an interval. So our lower bound, our equation, is x bar minus z alpha over 2 times sigma, which is our standard deviation, over the square root of n, our sample size. And our upper bound is x bar plus z alpha over 2 times sigma over square root of n. So why z alpha over 2? So you recall that our alpha is equal to 0. In our case, say 0.01. And what we need to do is we need to represent that alpha, which again is just a probability, on both sides of our probability distribution. So in order to do that, we actually have to divide it by 2 because our probability is represented on both sides. So this area here is alpha over 2, alpha over 2. So essentially alpha over 2 plus alpha over 2 is equal to alpha, which is this. And this alpha over 2 probability value is calculated at the point of z alpha, negative z alpha over 2, and then on the positive side of z alpha over 2. So essentially the probability here, so to the right of z alpha over 2, and the probability here to the left of z alpha over 2 combines together so that you get this alpha value, which is what we're trying to compute our confidence interval at. So now that we have an idea what our confidence interval is and what a confidence level is and what that means and how we can actually go in and compute it using different equations, let's go into Excel and actually work through an example. So in Excel, you can see that our data set is computer software engineers and their salaries. And we have 7 engineers and 7 different salaries. And basically what we want to do is we want to find out what these salaries tell us about the true mean salaries of the software engineers in the company. So what we need to do is we need to calculate the confidence interval, so a lower bound and an upper bound, and that will sort of give us an idea of where that true mean fits in there. So first we have our standard deviation of 15,000, and I sort of arbitrarily chose an alpha value of 0.01. Now in a lot of statistical testing, alpha is chosen to be 0.01, it could be 0.05. Those are sort of your most typical values. Sometimes it even goes to an even lower confidence level, meaning that we have a higher confidence that that true mean falls in the interval we're looking at. So the first thing we need to do is we need to calculate z alpha over 2, and again z alpha over 2 is just the norm S inverse of our probability, and our probability is based off of alpha. So in our case it's 1 minus alpha, but because we are at alpha over 2, it's 1 minus, in our case, alpha over 2. And we get a z alpha value of 2.58. So the next thing we need to do is calculate x bar, and that's just simply the average of our salaries. And then the next thing we need to do is we need to calculate the lower and the upper bound of our confidence interval. And so in this case, looking quickly back at our equations, our lower bound we're going to compute this way, and our upper bound we're going to compute using this equation. So to calculate our lower bound, our equation is x bar minus z alpha over 2 times our standard deviation divided by the square root of our sample size, which is 7, and we get a lower bound of about 65,000. And for our upper bound, it's very similar, except we have an addition step here, so it's x bar. For our upper bound, it's equal to x bar plus z alpha over 2 times sigma, our standard deviation, divided by the square root of 7, which is our sample size. And we find our upper bound to be about $94,000. So for our confidence interval, we have a lower bound of about $64,511, and we have an upper bound of $93,718, and that basically tells us where our interval is for our mean, and our mean falls in the middle of that, assuming that 99% confidence level. So I hope you have a better understanding on how to compute confidence intervals using confidence levels, the mean, variance and based off of our samples. So thanks.